of functions. So this is example differential equation, right? dy dx equals 2x. And we know the solution for this. That's a simple one, right? We integrate both sides. And we get a y equals to x squared plus c. Right? We see we have a family functions as a solution of this differential equation, because it depends on c. If sometimes we want to have a unique solution, we need to have an initial value, or at least 1 point. This is the second example. This is y double prime. Y double prime means d squared y over dx squared, right, equals to negative 9y. Excuse me, right? We could integrate, right? We integrate, and the solution will be like something like this: a cosine 3x plus b sine 3x. So a and b are representing some numbers. So again, we see a family of functions as a solution. So for this second one, we see if we start with this, with a function y equals a cosine 3x plus b sine 3x, we take a derivative of this. And y prime will be negative 3a sine 3x plus 3b cosine 3x. Right? Then we take a derivative of this again, which is y double prime. We get negative 9a cosine 3x minus 9b sine 3x. Right? And we see this is exactly negative 9y. Right? If we factor out the negative 9, factor out negative 9, open parentheses, we have a cosine 3x plus b sine 3x, which is y. Right. Or we can do this, y double prime plus 9y, we get 0, which is the equation given. If anyone has any question, feel free to stop me anytime. Yes, Shu Xian, right? Correct me if I didn't see your name right. Shu Xian, you raise your hand. You have a question?
No, I didn't. The last time I asked your question, you answered my question already. Thank you.
Somehow.
Go ahead.
You're welcome.
I guess. Thank you.
Okay. You're welcome. Anyone has any questions so far? Okay. So the two equations, so the first one is just y prime, we call first order. The second one involves second order of derivatives, so we call second order. We call second order differential equation, okay? Because second derivative of y. Okay, initial value problem. So the solution to a differential equation given the initial condition or conditions, so we can get to a unique solution. Let's see this example. Also, y prime equals dy over dx equals 4x cubed. And given initial condition, which is 1 point, right? X value is 1, y value is 3. excuse me. So the solution where we integrate this just once, so we get y equals to x raised by 4 plus a constant, right? So this is a family of functions. And with this initial condition, or we plug in this 1 point, x value is 1, y value is 3, and we can solve for c, we can solve for the constant. Just hold on 1 second. Sorry guys, I have emergency notes. Let me just quickly finish this. Sorry. All right, so given initial condition or 1 point, for this one, we still can solve for the constant c, right? So c equals to 2. Then we'll have a unique solution for the differential equation with the initial condition. And we call this particular solution. It's a unique solution, other than the general solution. So this is a family of functions. But this, with the initial condition, we get a specific, we get a unique function. If we have dy dx equals the function, or the second derivative equals the function, so we can try integrate both sides. Let's see this one. Dy dx equals x squared, square root of x cubed plus 1, with the initial condition. So y of 2 equals 3 means x equals 2, y equals 3. So a point, usually initial condition is a point or something. So this is just the first order, right? So we integrate both, integrate dy dx, we just get y. And the other side, we just try to integrate this. And we can use u substitution, right? We let u cubed plus 1. Okay, Sushan, I see your hand again. Maybe you didn't, and David too. Anyone has any questions? Yes.
What does g of x represent here?
Oh, g of x is representing any function. Just saying like this. G of x is representing a function. Let's see this one. You see dy dx equals to 4x cubed. So 4x cubed is a gx. G of x.
Oh, you integrated there too. I see. Okay.
Okay. It says use g of x representing any function. Yeah. You see also from this one, you see here, the second derivative, we can move negative y to the other side. So we see y double prime equals to negative 9y. In that case, g of x is negative 9y. It's just a representation for function g of x. Okay, we just integrate. So this is first level, first order. We just integrate dy dx, we get y. Integrate to the other side. We could use u substitution for x cubed plus 1, then du equals 3x dx. Then x squared dx equals 1/3 of du because we have x squared dx in the integrand. So this will be u square root of u, then 1/3 of du. So this becomes 1/3 of square root of u du. Right. Then we can integrate this, use the power rule. Right. That becomes 2/3 times u raised by u to the power square root. Then plus c. Then we substitute u back into x cubed plus 1. So we get a solution for the equation, which is a family of equations. And with initial condition, we're given this 1 point, 2, 3. We substitute in 2 for x, 3 for y. We can solve for c. So we get a unique solution. Okay, solve for c equals to -3. So we get a unique function as a solution to the given differential equation with the initial value. So that's it. So g of x in this case is just this, 2/9 of x cubed plus 1 raised by 3/2 minus 3. Anyone has any questions? Okay, David, you have a question? I see you raise your hand.
Sorry, I forgot to.
Oh, okay. All right. So let's see the second example. This is second order, right? And the g of x in this case is 6x plus sine x. So we just integrate d square y dx square. We get dy dx, we get the first order. Then we integrate the other side, 6x plus sine x. Integrate 6x, we get 3x squared. Integrate sine x, we get negative cosine x. Then plus c1, right? Because we have to integrate twice. So we use c1. Yes, question?
Oh, yes. For the general solution of the dy dx, but they have the power is different. Dy, the power is in the middle, but the x is the up of the x. So that's for the format.
Yeah, this is a notation for second order. This is the same
Okay.
as the for prime.
Okay. So we can do like a 2 pi like this, or also we can do this one, right? Both is same?
Yes.
Notation?
Right. Yeah,
Okay.
notation-wise, right, they're representing the same thing.
Okay.
I like to use y double prime because it's less writing. Yeah, d square y over dx squared. Let me just explain this because you're not in my class before. This may feel weird for you. Where does this come from? So we have dy dx, right? When we take a derivative of y, So this is same as y prime. But then we want to take a derivative of this, because what is this? This is a function. Right? This is a function. And we want to take a derivative with this function again in terms of x. You see how? You see we have d, dy. So that's why we get d square y. And the bottom is dx, so we get dx squared. Right? It should be dx parentheses square, but by convention, you know, mathematics is just everything's by convention. By convention, we ignore the parentheses. We just write d square y dx squared, okay? Which is exactly the same as y double prime. Okay, so this is second order. So we integrate once, we integrate second order, we get the first order, dy over dx, or y prime. Then we integrate the right-hand side, integrate 6x, we get 3x squared, integrate sine x, we get negative cosine x, then we plus c1. You could use C1 or you could use C. Then when you integrate it again, you could use letter D. Doesn't matter. All right. For this note, I use C1 and C2. This is y prime. Yes, you don't really have to raise your hand. Just speak up. Okay, just stop me, speak up. Yes, Shu, you have a question? All right. Then we integrate this y prime or dy dx, we get a y. Then we integrate this. So integrated 3x squared, we get x cubed. Integrate negative cosine x, we get a negative sine x. Integrate C1, we get C1x. Now we need to add another constant. So we use C2 or we can use D. If we use this one C, we can use this one for D or any letter you choose. All right. As you can see, this again is a family of functions, right? If we want to get a unique solution for this, we would need two initial conditions. One initial condition won't be enough because we have two variables. We have C1, C2. So at least we need two equations to solve for C1, C2. Or we need 2 points for the function to get to a unique solution. Okay, velocity and acceleration. So if we use x of t to represent a particle's trajectory, and we use a velocity v of t representing velocity, the rate of change, or x prime of t, or dx dt. This is just representation. Okay, don't feel weird about x. Right? We could use any variable we want. So x of t is just a function x in terms of t. Right? It represents a trajectory of a particle's movement. So velocity, which is the rate of change of x, which is dx dt, or x prime of t. Acceleration, we use a of t, right, which is d square x dt square, or x double prime of t, which is the first derivative of the velocity. which is dv over dt, or v prime of t. Let's see this example. A ball is dropped from 100 feet above the ground. If acceleration due to gravity is this function, negative 32, well, it's a constant, negative constant function, negative 32 feet per second squared. Second squared, so this is the second order, right? Acceleration. So find the position after 2 seconds. So we need to find x of 2. Right? We use this notation. So x of t is a position, v of t is velocity, a of t is acceleration. We're given acceleration, and we know the height is 100 feet above the ground, and we want to find the position after 2 seconds. So we want to find x of 2. So we need to solve the differential equation, which is d squared x dt squared equals negative 32, right? So basically a of t is given, it's negative 32. And the initial condition we have x of 0 is 100. And velocity v of 0 equals 0, because when it hits the ground, it's normal velocity. So we have these 2 initial conditions. So velocity is negative 32. Well, that's the derivative of not velocity. Acceleration is negative 32, which is the derivative of the velocity. So we integrate acceleration, right? We get a velocity because acceleration is a derivative of velocity. So integration of a is the velocity. Then we integrate to negative 32. We get negative 32t plus a constant. Then we use this initial value to get a c, to solve for c. So in this case, c is just 0. So get a velocity function is negative 32t. Then we integrate again the velocity. Integrate the velocity, we get x of t, right? Because v of t is just x prime of t. So get an x of t. Then integrate negative 32t. We get a negative 16t squared plus a constant. Then we have another initial value, 0, 100, right, for x. So we plug in 0 for t and 100 for x of 0. We see c, so for c equals to 100. So we plug in c. So x of t equals a negative 16t squared plus 100, a downward parabola. Then we need to evaluate at t equals 2. We get x of 2, which is plug in 2 for t, we get 36 feet above the ground. Yes, question, David.
So the 0 for the v, where it says v of 0 equals 0, that 0, is it mean at the ground or like where it's being held before it drops?
Exactly. When it hits the ground, because
Because when it hits the ground,
yeah,
it has velocity. It just stops instantaneously.
that's right. Any other questions? All right, so that's it. So 2 seconds, so the position is 36 feet above the ground. Let's see this example. A ball is launched straight up with an initial velocity of 96 feet per second from a point 256 feet above the water. If acceleration due to gravity is negative 32 feet per second squared, and we want to find the time t when the ball hits the water. Okay. So we have this differential equation, acceleration of t. So a of t equals negative 32 again, negative 32, which is the derivative of the velocity. And then we have two initial conditions. So at time 0, it's 256 above the water. And the v of 0 equals 96 because we're given this initial velocity of 96. So v of 0 equals 96. So we see second order, to solve second order a differential equation, we need two initial conditions. So similar to the first example, right? We integrate a of t, we get a v of t. We integrate negative 32, we get negative 32t plus a constant. Then we use the initial condition of v of 0 equals 96 to solve for the constant. The constant is negative 6. Then we plug into the velocity function. Well, velocity function is a linear. And of course, right, acceleration is a constant function, so velocity is a linear function. Then we know x of t has to be quadratic function. So we integrate v of t, we get x of t. And then we integrate the negative 32t plus 96, a linear function, we get a quadratic function. Right, negative 16t squared plus 96t plus a constant. Then we use the initial condition, 0, 256, to solve for the constant. The constant is 256. Right, so we see the function, the original function is a downward parabola again. Any questions? Yes. Yes, David.
I think the same problem again. Sorry, I haven't been in online class a while, so I forget to lower my hand.
Oh, okay. That's all. Anchi, question? Anchi, I cannot hear you. Okay.
I have like a more general question,
Yes.
like about the class. Because we only have one final, and I think it's in person, right?
Yes. It's on campus.
Would it be possible for us, like, who makes the final? Is it you or the department?
For this class, I make the final.
Okay, so we can kind of know, like, will it be like the homework questions? Because I was gonna ask if I could like see a past final, because sometimes they do that, just to know, because like, since we're not taking any other exams.
Okay, you're exactly right. So homework, basically your review questions will be very similar to your homework.
Okay, thank you. That's helpful.
You're welcome. No surprise. All right.
I think my audio is working. Can you hear me?
Yes, I can hear you now.
Okay, perfect. So let's say instead of it is launched directly into the air, the ball is thrown straight down. Would it be a different formula?
What do you mean? You mean you don't toast to the, you don't shoot up, you just toast down. All right. Think about the parabola, right? Because when we toast up the ball, the trajectory is a downward parabola. If you dive into water, let's think. Let's see, you're a swimmer, you dive into the water, you'll make an upward parabola. But if you toss ball to the air or you toss down, even you toss down, the trajectory is still part of a downward parabola.
Mm-hmm. So the formula would still be the same.
Yeah.
Okay.
Yeah. Yeah.
Thank you.
You're welcome. Any other questions? Albert is seeing, okay, David is seeing negative velocity. Albert is seeing, are the recordings being posted? Yes. Do you know where to find the recordings? Before you get into the class, there's a 3-bar. Oh, you see right here. Something like this, like a 3-bar on Blackboard. Right, let me show you how to get the recordings. Oh, actually, I need to go back here. So when we go to classroom, we go to Blackboard Collaborate, right? You see this 3-bar right here? You click on this menu bar. You see the recordings right here. Nothing's here because it's been recording. It hasn't been posted yet, but it will after we finish our class, probably like 5 minutes afterwards, it will show up here, all right? So basically, you click on the menu bar, you click on Blackboard Collaborate, because this is how you click this, you get into classroom. You click on this menu bar, so recordings should be here, okay? You're welcome. You're welcome. Excuse me. Okay, right here, right? So when the ball hits the water, that means the height of the ball is 0, right? So we want to solve this, we want to solve a t for this equation. So we have the function, the downward parabola, right? So equals to 0, we want to solve a t. So we can factor out this quadratic. We have these 2 linear ones. Then we have t equals 8, t equals -2. But we don't measure time negatively, so we ignore this negative value. So basically, after 8 seconds, the ball will hit the water. Oh, that's it. That's it for today. And anyone has any questions? Surprise, huh? Surprise. Yeah. Catherine is, oh, okay. Catherine is trying to make a group study. That's nice. Oh, sure. Yeah. And you can speak to me after class. Now let's see. Let's see homework. Let's see the assignment 1. Let's see what's on your homework. Oh, easy, easy. Okay, so first homework is very easy. I know some of you are pretty advanced in this class. You know, some ones I know in this class has a very good habits of studying on yourself. So what you could do is you could just keep going because I have posted all the notes. You can get ahead of us, okay? You can get ahead of me. And then maybe sometimes, because I'm teaching 4 classes this semester, I'm teaching 3 classes at Hunter College and 1 class for Brooklyn, which is online, which is this one. Because I'm very close to Hunter College. I could, if I want, I could just walk to it. So maybe I will have you guys to teach the class sometimes, okay? All the notes are here. Bixin is in, did you take attendance already? Well, I have attended, not yet. Some for first class, yeah, you're late, that's fine. But try to be on time next time. All right. Try to be on time next time. Yeah, question, Su Xian.
Oh, for the homework, so I need to write down on the paper and upload to the Blackboard, or just and do in the Blackboard like that?
Okay, right, you're new to this system. Let me show you how
Yeah.
to do that.
Mm.
So you go to assignments.
Mm.
Right, first you write on the piece of paper.
Mm.
Right, so you write down, then you upload. Let me see how to upload. So usually when you click on this, on your end, right, you see
Oh, I
create.
upload.
Yeah, upload files. All right. It should be easy. It's not difficult. So Blackboard is very, very easy to use. But when you finish 3 of them, okay, you only have to upload once. When you finish 3 of them. All right. Any other question? Yes, Israel.
Oh yeah, pardon me. So I have a question for the presentations. When does it end? Like when do we present, pardon me? Like during class?
Oh, you can present next class. But now for this class you have to fight because there are less questions.
Oh, okay.
The summertime, right? Summer session we have a lot of questions, but for this class, yeah, I didn't give you too much.
No, yeah, but
option.
I was asking more like what time to be present during the class, like.
Oh, before class, you know, at the beginning of each class.
Okay, yeah.
Yeah.
Because I don't.
So, because presentation serves as a review also. So each class, at the beginning of each class, it's your time to present. But because we don't have, you see here, the first homework, we only have 5 questions. So which means only 5 people can present.
Okay.
Okay. Let's see second homework. Right, each homework, oh, this one has 9. Oh, this one has 11. Good amount. Right, Ryan is saying, right, we have no chapter. You're right, because I have these notes. You just go by homework, all right? So by homework 1, question, let's see, let me type in the chat. Just let's see, homework 1, question 4. You just use this to indicate, okay, 1.4. Homework 2.11. 2.11 to represent the question you want to present. Right. Let's see. Right. Can we present a homework question before you cover it? Ryan, I would love to have you to teach a class. Just go one. You may go one section before, okay? You can go as fast as possible for your own pace, but for presentation purpose, don't go too far. All right, if you present too far away, it won't make sense for the rest of the students. You can go one section ahead of time, which is the time to teach us. All right, I'm going to use your line. I'm going to use you for this semester. So you prepare, you may teach the class, all right? At 1.13 right now. No, David, next class. Next class. Just 1.3 or 1.1 because we only have section homework. So homework 1. Oh, okay. 1.13 makes sense. Homework 1, small homework 1.3, question 3. Okay. All right. David is right. David is giving us a perfect example, saying if he wants to present big homework, capital letter HW, that's 1. Then lowercase HW, that's 1. Then 3. Okay, let's go by this format. So homework 1, and then small homework 1, then question 3. Right, you may not claim now, you have to claim Thursday night. Yeah. All right, if you have no more questions, you are a free bird for tonight. You can go ahead to do homework 1 and prepare to present on Thursday night. I like the picture, Gregory. Thank you. And if you want to talk to me, I'm here. Okay, Jun E, nice to see you again. I think I know most of you. Only a couple of you I don't know yet. Okay, someone wants to talk to me, right? Thank you, thank you. Have a good night. Have a good night. Have a good night. Oh, Anchi, yes, Anchi. You want to wait for them to leave? Thank you, thank you. Good night, good night. Oh, thank you. Have a good night.
Of course. See you on Thursday. Have a good night.
Have a good night.
You too. You too. Okay, while we're waiting, I can create. Have a good night. Thank you. I'm going to stop recording.